We're gonna go out and collect some samples today.
It's a frigid fall morning on the Tillamook Bay.
We're loading up, we've got all our equipment. Just gonna go out to the marina and west and down the West Channel.
Researcher York Johnson and biologist Ron Wren
He's been gracious enough to take us out to our site today.
set out on their last research expedition of the season.
I'm happy with sunshine and a little wind.
And they invited us to come along.
We're headed south down the West Channel.
This is the front line in the study of how climate change is changing our oceans and impacting marine life, specifically oysters. Something in this water is killing them, and these researchers want to stop it.
It's about a 10-minute boat ride from the marina out to the test site. It's late October, so it's pretty chilly out here. Temperatures in the 30s, but at least it's not raining.
This was the day I was most worried about because, you know, it's getting closer to the fall and winter season.
But when so much depends on your research, a little sub-freezing wind and near-freezing temperatures
All right, we're at the site.
don't really
There
matter.
are buoys right in front of us. Okay.
Because what these scientists are studying is a big
All
deal.
right, here we go. It's really important.
To truly understand just how important, we'll have to rewind the story about 12 years.
We came in here one day and we had billions of larvae that died overnight. Nothing in this facility was alive. Mass mortality.
It was a day shellfish farmer Mark Weigart remembers vividly.
We had no idea what was going on.
Weigart was working at the decades-old Whiskey Creek shellfish hatchery in nearby Netarts when one morning in 2007 he arrived at work to find every single young oyster dead.
The shells weren't forming. They were just damaged from the get-go. And we thought it was a bacteria. We had no idea what it was. Within a week, we had people from the governor's office here. We had Oregon State scientists here.
We saw some pretty severe problems with oyster larvae.
Even we came to the hatchery to cover the unexpected and mysterious mass die-offs.
We had about 90% mortality of oyster larvae in the hatchery.
Researchers eventually traced the die-offs not to any bacteria or disease, but to the water in the bay. You see, the water the hatchery uses to grow the oysters in the tanks is pumped in directly from the bay.
This is our source right here.
Scientists got to work testing that water and quickly discovered high levels of CO2.
This is Netarts.
The water in Netarts Bay had actually gotten so acidic, the juvenile oysters couldn't form shells and died.
And then next thing you know, somebody said, well, it's ocean acidification. We really didn't know what that meant.
But they would soon learn. Ocean acidification occurs when carbon dioxide is released into the atmosphere from the burning of fossil fuels. About a third of that CO2 gets absorbed by the ocean. Once dissolved, the gas combines with the water and forms something called carbonic acid. The more the CO2, the more acidic the water. To survive, the hatchery had to find a way to make that water less acidic.
We got to throw the book out on how we raise oyster larvae. We're not dealing with the same ocean. The reality became, we can't fix the ocean, but we got to fix the water coming into the hatchery. After the water comes in,
Now all the water that comes into the hatchery is treated with soda ash.
as you can see, it's pumping the buffering agent right into the main line.
To increase the pH levels so the juvenile oysters can form shells and survive.
It's like a morphine drip, you know? It's taking the pain out of the water. There's all these little tricks you learn along the way, and if you know, you can't learn them fast enough.
The water coming in from the bay is constantly monitored. The hatchery even set up a special room
There's a percolator here.
just for researchers,
This is a monitoring system. This is scientific data being collected.
Yeah.
which brings us back to Tillamook Bay and on board that small research boat.
Perfect, just up a little closer. This was a kind of an eye-opener for Oregon and the West Coast. And basically, Oregon decided that it needs to set up a monitoring network to see, to track changes in ocean conditions. So the goal of this effort is try to establish a cost-effective way to monitor ocean acidification over the long term. All right, here we go.
For the last year, Johnson has been tracking just how acidic the water in this bay is.
Yeah, the sample collection is pretty quick.
The final samples of this testing season.
Right.
Measurements are taken.
Salinity is 19.9.
The water temperature recorded.
Temperature is 7.8 degrees C.
Yes, that's a beer bottle Johnson is holding, but it's not for drinking.
So what do you got there? That looks familiar.
It's just a normal beer bottle. Yeah.
It holds in the CO2 when it has beer in there, and it holds in the CO2 of the sample.
Exactly. This will be a little flatter than your typical beer, though.
It's filled with bay water, then capped.
This is going to OSU, this is going to OHSU, PSU. That's it. That's a wrap.
Now that the samples have been taken and the equipment pulled, the next step is to get those samples to researchers so they can figure out what's really happening with the water in this bay.
They already know the ocean is acidifying. That data is clear. What they're hoping to learn with projects like this one is how fast it's changing and how marine life will adapt. The problems that started with the oysters are already impacting Oregon's mussels. While the adults will survive, the young mussels likely won't be able to. Researchers believe Dungeness crab could be next. Then there are the salmon. Studies have shown acidic water impairs the ability of fish to find their way home. Acidic water will reshape our ocean. The question now, what will it look like in 10, maybe 20 years?
Is there anything we can do?
Well, I think that's one of the questions we would like to answer, but I think, the hope is that yes, there is.
We have monitors here that...
It's a hope those who depend on the ocean for their livelihood hold on to, despite what many are seeing.
Has the pH gotten any better? No. I think it's actually gotten a little worse. It's just that we're a little bit, now that we know what we're dealing with, we're a little bit better at dealing with the problem. So that's larvae there.
In the 12 years since this crisis began, Whiskey Creek has become somewhat of a poster child for the problem.
The Whiskey Creek story about ocean acidification just never seems to go away. People want to hear about it a lot. And of course, we live it, so sometimes we'd like to have it go away.
But they know this story will be told for a long time, a story about a vast and beautiful ocean that is sick.
There are actually things that we can do, each and every one of us, to make it better. Someday, we'll all get to that point where we don't have much time left in this world, and you're going to sit there and you're going to wonder, did I do enough?
They are big, destructive.
It's all around us.
And as our climate continues to warm,
we're still trying to wake some people up and get them out of here.
they will get worse. We've watched as massive wildfires devour forests, towns, and neighborhoods, but their impact is felt much farther away. Because where there are flames, there's also smoke that can travel long distances. This season, we've watched smoke from fires burning along the West Coast.
Unfortunately, the haze is coming at the expense of some massive wildfires out west.
Blew across the country.
Yeah, it's a U.S.-wide problem. I mean, even if the fires are contained to the western U.S., we're seeing impacts across the continental U.S.
It's a phenomenon Portland State University Assistant Professor Elliot Gall has been studying.
But we've always known that, large-scale wildfire events can impact entire regions and, in fact, have global impact. But I think as we see hotter and drier summers, we're seeing larger fires.
And the larger the fire, the more its smoke will travel. Here's why. A large fire can actually generate its own weather and create conditions that allow the smoke to reach the upper levels of the atmosphere. Those upper levels are where you'll find the jet stream, strong and consistent winds that can push smoke over great distances, causing not only hazy conditions, but also serious health problems.
As I understand, New York City saw an air quality index of over 150, during those few weeks when they were, impacted by the fires in the West. And that's a level that's sort of of acute concern to the general population.
Gall and many scientists are tracking the movement of wood smoke through low-cost sensor networks like this one.
This sensor here is called a purple air sensor.
These sensors measure the levels of particulate matter in the smoke. You can see even in cities far from the wildfires.
Let's pan over and take a look at what's happening in Denver.
The levels are disturbingly high.
We're seeing air quality indexes of 140, 150. These are levels of outdoor particulate matter that the general population should be concerned about.
Which raises the question, if a warming climate will lead to more and larger wildfires, is there anything we can do to protect ourselves?
Experts say better forest management will be critical because once the fire starts, there is little that can be done to remove the pollutants from the atmosphere. What we can do, says Gall, is to at least remove them from our homes as much as possible.
Preparedness is really key.
Number one, invest in a mechanical filter, a filter that filters out those wood smoke particles. Secondly, purchase an air cleaner, something Gall says we should all have regardless.
If you purchase an air cleaner and use it regularly, there is a robust body of evidence that shows it will improve your health over the long term if you use it regularly.
And lastly, create what's called a clean room in your home.
Basically, selecting a zone in your home and emphasizing and focusing your resources in a small zone of your home like a bedroom.
This is something even the EPA recommends we all do because scientists realize as our climate warms, large-scale fires will become more frequent.
And so, I don't think this is a Western U.S. problem. This is a global problem. This is a U.S.-wide problem. It's one we collectively need to work together and address.
Keely Chalmers, KGW News.
Rising sea levels, shrinking ice, and much more extreme weather events like storms, droughts, and heat waves. They're all trends that have increased over the last several decades, and according to a new international report, these trends will get much worse in the future. The United Nations Intergovernmental Panel on Climate Change, or IPCC, report released this week says Earth's climate is getting so hot the temperature limit set in the 2015 Paris Climate Agreement will be surpassed in about a decade.
And looking to the future, we are continuing to look at the possibility of a really scary amount of warming.
Philip Mode is a climate scientist at Oregon State University. He also worked on two previous IPCC reports since 2000, and this one shocked even him.
Honestly, my heart sank. When you bundle, 8 new years of science and observations into one package, it really is a very sobering read.
The report says as the planet warms, places will get hit more, not just by extreme weather, but by multiple climate disasters that occur simultaneously. It also makes it clear humans are to blame.
Approximately 100% of the warming in the last 50 years is because of human activities.
They could not say it too strongly that we are in a climate crisis.
OSU ecology professor William Ripple has long studied our climate crisis as well. He says this report sounds the alarm that we are running out of time. Ripple recently published his own report outlining solutions. The first, cut carbon emissions drastically.
So we're suggesting that we immediately start phasing out fossil fuels with an eventual ban on them. And one thing that might help is to put a price on carbon.
Second, his report calls for the development of global climate reserves, natural solutions like leaving forests uncut.
Yeah, so we're calling them strategic climate reserves, but these are really nature reserves to store and sequester carbon.
Ripple says it's also critical schools start adding climate change curriculum because these scientists know all too well the future we leave for our children is one they will need to be prepared for. Keely Chalmers, KGW News. It was during a routine trip to round up underwater instruments that Oregon State University marine ecologist Francis Chan discovered something he didn't expect.
Really surprisingly, the oxygen levels were still really low. And in fact, what I saw just last week was the lowest that we've seen this year.
When you think of low oxygen zones in the ocean, these images might come to mind. This video was taken back in 2006. It shows dead crabs littering the ocean floor, the result of no oxygen in the water. It's also called a dead zone.
And it's turned out to be a really bad year.
Chan has been tracking dead zones for more than a decade. Back in spring, he correctly predicted a dead zone this summer.
We started this story early because we thought that we might see this, and unfortunately, we were right.
But what he didn't predict was just how long it would last.
Low oxygen, it started back in April, so it's been months and months and months, and that's a really long time to hold your breath.
He also didn't realize how far it would reach. Last week, OSU oceanographer Jack Barth was conducting research off the central Washington coast when he too found very little oxygen in the water.
I think this late in the season, we start to expect the change to come and the winds to shift and maybe wash out some of that low oxygen water, but not yet.
The result, sea life like crabs have been moving to shallower areas, causing a reshuffling of sorts in our ocean.
So it really does affect how those populations are distributed along the coast. And therefore, as we go out to fish, either commercially or for fun, things are disrupted.
I think the thing that is worrisome is that this kind of warmer, more summery weather, that's the shape of things to come with climate change.
It's a change these scientists suspect will become the norm in our changing climate. In the meantime, they're just hoping the fall storms return things to normal, at least for a while.
Hopefully the next time I talk to you, I can tell you that the 2021 hypoxia season has ended.
Keely Chalmers, KGW News.
This little grove of Douglas fir trees have been included in our study.
On the western edge of the Reed College campus,
So this is just one site of many.
sits a study site more than 100 feet tall.
So these are two of our subject trees right here.
This grove of Douglas fir trees will give researchers a glimpse into the future and how all trees will handle a changing climate.
So trees in urban centers are really good proxies for they're exposed to high temperature, increased CO2, and things that we predict to be in future climates.
Students have already collected branch samples for testing, but soon they'll be turning these normal trees into smart trees.
This summer, students will be climbing 100 feet up into these trees to install special sensors. These sensors will be able to track exactly what the trees are experiencing in this urban climate.
These are sensors we leave in the trees that give us information not just on the trees themselves, but also on the environment around the trees.
In addition to studying how the trees are handling the environment around them, the researchers are also studying how those stressors are passed down to communities that depend on those trees for not only comfort, like shade, but also health.
Just to understand how trees can continue to provide the services that we need in our communities in terms of cooler air temperatures and reduced air pollution.
It's a tall order, but one these researchers are ready to tackle to find out what exactly is happening 100 feet up in the air to our trees, our forests, and our environment.